Okay, so good morning, good afternoon, or good evening if you're outside of North America. Here in North Texas, it's a little after 12 p.m. local time, and we want to welcome you to the Tech Titans Internet of Things Special Interest Forum presentation on using 5G to make 5G, an introduction to Ericsson Smart Factory in Lewisville, Texas. I'm Russ Donnelly with TossiBox, the program chair for this event, and one of the tri-chairs of the IoT Forum. I'm joined today by the other two tri-chairs, Andy Sloat and Ed Hightower, both of Object Spectrum. Before we begin, there's a few announcements we want to make the program run a little more smoothly and effectively. Paul C. of Ericsson will run through his presentation uninterrupted, although you may ask a question via the chat feature at the bottom of the screen. Please identify who you are, the company, and where you're located. I'll then ask the question on your behalf, either at an appropriate time or at the end of his presentation. At 1 p.m., we'll adjourn this part of the presentation and we'll immediately go into the extended Q&A. It's a /networking session Q&A till approximately 1:30. This one's going to be a little different. During this time, you can raise your electronic hand, and when you're called on, you can unmute yourself and offer your comment or ask your question yourself. Tech Titans has a few programs planned to the end of the year, and one that I want to make you aware of right now. The last Tech Industry Luncheon is tomorrow at 12 noon. 3 years ago, Lucas Rodriguez, CEO of Cerecy Therapeutics, designed a technology-based method for managing pain without the use of opioids and just had a multi-million-dollar exit. Lucas will discuss the technology and the path he took from startup to the exit. You can find this information and register for this event at www.techtitans.org. So the IoT Forum is in its 6th year of producing excellent programs on IoT networks, applications, and use cases to help our audience understand a deeper understanding of the technology and its effect on business. One of the ways in which IoT is being deployed is through industrial IoT, or smart factory applications. Here in North Texas, we have one of the most advanced state-of-the-art smart factories in the world, the Ericsson Smart Factory, which recently began producing 5G radios and antennas to deploy in global communication networks. With the demand for 5G radios greater than ever, the Ericsson Smart Factory is combining IoT with Industry 4.0 to make radios with lower power, smaller form factors, in higher quantities, and at lower costs. I'm pleased to introduce today's speaker, Paul C. Paul is a 5G solutions engineer for Ericsson North America based in Plano. He's responsible for helping operators roll out new radio solutions and technologies to create brand new use cases. Paul joined Ericsson in 2010 from Nortel and has held roles from Radio Systems Research and Development, RF Engineering, Product Management, to his current position in solution sales. Everybody, please welcome Paul C. of Ericsson.
Great. Thanks, Russ, for the introduction. Let me just start by sharing slides then to kind of keep us on track. Very good introduction. Actually, I didn't even remember all of that of myself. Mallory, can I get the sharing permission? Okay, great, thanks. All right, can you guys see that? All right. So yeah, like Russ introduced, I'm here to talk about how Ericsson created a smart factory in Lewisville, Texas, where basically, we're trying to use our own 5G technology to help us make 5G products. And so as Russ described a bit about myself, I joined Ericsson in 2010 from Nortel. I've basically been sort of a solutions engineer, mostly focused on the radio side. And I've been working on 5G since 2017. As you know, in the early days of any technology, you're doing proofs of concept, you're trying to make sure it works. And so we did a lot of that, with events like at Indy 500. But then starting from 2018, we had this ambition to create a factory in the US. There are some global economics and other factors that kind of motivated this. And then, as you'll hear, sort of COVID hit, and it made it even more imperative to be able to do stuff like that in the US. So the QR code in the middle, if you want to connect with me on LinkedIn, that's my LinkedIn thing. And the picture on the right is me at the factory. So we have a lot of COVID protection, and we actually measure your temperature. So that was a cool picture of the thermal image measuring my temperature there. Okay, so our factory is in Lewisville, Texas, as you can see from this picture. It's a large facility, around 300,000 square feet. And we broke ground around October, October 2018. And we're already producing radios since about mid-year. As you can see in the foreground, there's solar panels, and kind of in the middle here, there are these water reclamation storage systems and air conditioning chillers. I'll describe a little bit about them. But basically here, what we're producing are 5G radios for our North American customers predominantly. So I wanted to give an idea of what we make, because then when I explain, the technologies we deploy and stuff like that, it kind of makes sense, right? So 5G radios, especially, with the newer bands in millimeter wave, are small form factor. They're like bookshelf speaker size, or like a shoebox, about this big. And, they'll have an embedded antenna because it's millimeter wave. There's a lot of antenna elements in it. And then circuit boards for the processing, and then fiber optics and power supply coming out the bottom. And so the reason it's good to understand that is you can see that this can apply to you guys too, no matter what industry you're in, right? If it's electronics manufacturing or any other, a lot of what we went through and talked about and did for our manufacturing excellence can apply to other manufacturing areas. So the business need, kind of as Russ pointed out, right? We have 5G radio production. As you know, 5G is kind of the big thing right now, and there's a lot of new spectrum being allocated, which means that operators, to give you better spectrum, better performance, let's say you buy a new iPhone, you need more radios for different bands. Additionally, some of 5G gets you more bandwidth, but smaller coverage. So we need more of the radios. And so we try to make them smaller and have better performance for nearby users. So there's a growing market, which means we have to produce more. The second point below that is the close proximity to customers. In North America, we have millimeter wave, which is a spectrum pretty well unique to North America. In the rest of the world, it's mostly midband. And so by making our products close to customers, we can react faster, we don't have to ship as far, and we can meet their demands more quickly, right? So there's a shorter cycle time. Below that, automated production. This is really important. I don't know if people have tried to hire recently for manufacturing in the United States. It's very difficult, right? The skill sets are declining in terms of the number of people in the area. The sort of the ecosystem is basically offshored, right? So we needed to be able to reduce manual processes and try to scale up with the few people we can get, and put the few people we can get to max productivity by taking away, tasks that can be done by robotics and machines. On the other side, we wanted this to also be a factory showcase. You've probably seen over the past few years, like I said, I've worked on proof of concepts, POCs, which basically show the potential of 5G, right, because of the lower latency and stuff. And we wanted to put that to use in our factory because we think that it can give us some advantages in being more agile and stuff like that. I'll talk about some of the things we've done. Fifth, optimized processes. So again, it's all about efficiency, right? If you're building a new factory, you're expected to be more efficient, and you need to have good quality. You have to meet the targets for a number of products you can put out for the capital investment, right? So we're forced to optimize because some of the costs in North America are a bit higher, right? So it's important for us to have as much as we can. And then sustainability. So that's really important because it's not just a feel-good thing. Actually, some of our customers demand it of us, which is a good thing, right, for the whole ecosystem. So not only is it the right thing to do, then I think Ericsson would have done it anyway. But it's a business imperative because of that. So I think it's a good consideration for everyone to appreciate. So some of the manufacturing challenges then are that, like I said, we're building products closer to our customer. But as you can imagine, when you're deploying radios and stuff, you have to acquire spectrum, you have to acquire sites, and every municipality, might be different, right? So the demand shifts. And so you might have one product in one band, in 1 week or month, and then suddenly you got site acceptance from a different municipality, and you're ready to go with a crew there. And so you get product shift, and being able to customize is something we've seen. And from the literature I've read, it's a trend across all industries, right? Customization, so you mass produce, but in small batches, right? And you have to maintain efficiency while doing that. The local production footprint, again, is important. Basically, when your supply chain has all these global issues, and COVID really exaggerated all of these things, right, and cranked it up. So being able to have your supply chain located closer to your customers is super important. And then, like I mentioned before, the shortage of competence is something that forces a higher degree of automation, which is a good thing. It levels the playing field when you think about China, Mexico, Brazil, and all that. Automation means everyone's kind of on the same, cost basis for the machinery and what you can do with it, right? So you take out the equation of people and availability of labor. So you guys probably all know about Industry 4.0, so I'll just kind of rapidly go through it. But basically, from mechanization through, electronic machinery and then automation to what they call cyber physical systems. To me, that's a lot of it sounds very theoretical, right? I rather think of it like an analogy of, we've all used GPS navigation. So if you think about GPS navigation, you had maps, right? Just paper maps, and you could get places. And then you had MapQuest, where you could go online and print out directions, but you'd have to follow them, right? So at night, driving from the airport, kind of a pain. And then say 3.0 would be like Garmin, right? So you had Garmin, it told you where you were. If you're going to miss an exit, it could kind of figure that out. So you got to where you were going. Now 4.0 would be like Google Maps and Waze, where you knew where there was traffic, where there were police, where there were congestion or construction. You had feedback from the data collected live to help you make better decisions. So if you look at that as an analogy for Industry 4.0, you're able to take advantage of data, real time, and feed it back to make better decisions. So that's kind of a theme that for all of our automation and a lot of what we do, that's what we're trying to take advantage of in a manufacturing context. But I think the GPS analogy helps you understand how even you are benefiting from this theoretical improvement. Right. So like I mentioned, when we go through this, so not everything we do is about, fourth industrial revolution. Some of it, like I said, solar panels and stuff that we do is because it's the right thing to do and we should do it, right? And it helps us save cost as well. So in addition to, all the other stuff I described, think about the data, right? Everything we do, how is data involved and how are we using it? Okay, so this is less about the data, but like I said, sustainability is super important. One of the factors we had in building a factory is to make sure that we had leadership in energy and environmental design, right? So sustainability. So as you can see in this picture, which I took at our factory, this was a while ago, so the solar panels you see in the foreground here are completed. But on the left, you see these water storage tanks, right? We collect rainwater and reuse that for some of the water sources in the factory. And so that helps us save, as you know, in Texas, right, water, it's a big deal. Another big deal in Texas is heat. So we have these super efficient chillers that use, sounds super cool, I don't know how they do it, but it's like magnetic levitation chillers that have much lower friction. And we even use technologies to time shift how we cool and heat. So in the evenings when we're off peak times, we can chill and store some of that coldness in ice, and then use it back. So like ice is like a big capacitor, right? So we can use that back and time shift our energy consumption. So that's, smart things that doesn't cost a lot to do, but it's a really important thing to be considered of in our energy consumption. And then finally, kind of very visible is when you drive past the factory, there's these giant solar panels, which are really cool looking. And they provide about a quarter of our energy consumption. So the rest comes from, carbon neutral sources, right, like wind and stuff. But it was important for us to do as much as we could locally while not, going out of our way. So not only are these solar panels really cool and provide energy, but they provide covered parking, which our employees super appreciate.
Hey, Paul, question.
Yep.
Does the factory currently meet LEED requirements? Can you talk about that for a minute? What's the plan there?
Yep. So we have designed, so in the whole construction, design and build and operations, we are complying to LEED Gold certification. I don't think it's been awarded yet, but that's our ambition. And so that's how we're operating. So whether or not we get that is where we have aimed and are operating at.
Okay, thank you.
Yeah. So LEED Gold and zero carbon, I think, are the two things. Yep. And so sort of cute, and I don't know how popular it is in Texas, in Lewisville, that we have bike parking, which I thought was really neat. And there are lockers so that, you can put your helmet and your gear. And there's also a lot of electric car park charging stations along the front. So I think it was just very good. I mean, that's something I always liked about our company is just, considering the eco-friendliness of everything and making it easy for our employees to, to be eco-friendly, right? So that was really cool. So part of the process then is, like I said, in October of 2018, we kind of broke ground. So when you're starting brand new at the factory, it's not like you have a starting point to say, oh, I know I need to improve this thing, right? I need to fix that. So when you're starting with a greenfield design, you have a lot of freedom, but then you don't really know where to start. And so it was really important then that when we looked at it, we looked at our other factories and partners and really tried to understand what were the business problems to solve, right? So it's not like, hey, let's buy some drones and use AR and fly around and stuff, right? Because it's cool and we could do a POC. Like we did that for 5G through 2017. This was really time to apply serious solutions. So part of what we did was then to build diverse teams to make sure we had good feedback from factory operators. And this is really important because there is a tendency to have a company say, okay, yeah, we're going to do Industry 4.0. Let's hire a bunch of data scientists and AI people and make them do stuff, right? But the thing is, they don't necessarily know what stuff to do. So they can collect all your data and format it well, but you're not really solving problems. So it was really important, and I enjoyed this aspect of working on the factory is we built these diverse teams. So imagine me as an RF engineer, like what am I doing helping with the factory? But the thing is, if you can think at a systems level and listen to the operators on the factory floor and say, so, when you do this, right, what happens? Oh, what's the biggest problem? What annoys you, right? What could make things faster? And you listen to them and you think, okay, hey, in my toolkit, right, I can solve it this way. And you have other people, right, a diverse team that have other toolkits. So there might be an AI person that says, oh, hey, we can process this, right? We have this great image classifier, blah, blah, blah. And so the process involved really assembling diverse teams to think about the problems, listen to the end users, and create those user stories, right? So, and then once you get to the point of saying, okay, here are things we're going to do, right? Here's our plan. We lay it out, build the teams to do it, and then we work in sort of an agile fashion. I think we try not to get hung up on like capital A, agile as a process, but it's more like the spirit of it, working together, sharing often, pivoting, right? So you do an MVP, right? A minimum viable product or project. So instead of having a 2-year window where you're going, at the end of 2 years and lots of dollars, you're like, oh, that didn't solve the problem, right? So you're going in these very short sprints, and you're saying, yeah, that seems to be right. Let's look at it, talk to the operators again. And so that process, I think, was super important in making sure we were on the right track. We pivoted a lot, right? As you can imagine, with new technology and stuff. So I think that was a key part of ensuring our success. And in the middle here, I glossed over it, but if you're buying a solution too, right? So there's a lot of new technology, 5G and digital twins and augmented reality and stuff like that. You're not going to have all of the expertise in-house. So we worked with, once we understood our requirements and what we wanted to do, we then issued RFIs, or requests for information, and RFPs, requests for proposal, from vendors that were leading in this industry. So we consulted with, trade publications to see, who was best in class. But you kind of shop around, and it's really important because our vendors are really good. Like, they're trying to sell you stuff, but they're also trying to educate. So when we get to the topic, for example, of digital twin, right? There are a lot of digital twin solutions, and if you look up the definition, it is all over the place. So there's all sorts of dimensions on that. And so we had to be very clear, well, what did we want to accomplish when we meant digital twin? So that's one example. And so once we got through that, then each vendor you talk to, you can kind of, narrow down their definition. So that was really important. And so it's not like, don't just follow the hype and say, oh, Paul said you should do a digital twin. It's super cool. And go and buy one, right? So you got to really make sure it makes sense for you and solves a business problem, and get that information. So I won't cover this, but we did classify use cases so that we could assign teams and figure out who had the right skill sets. But in the next few slides, I talk through some of the use cases.
Yeah. Hey, Paul, we got a question.
Yep.
Can I stop
Sure.
you?
Yeah, absolutely.
Yep. So Solomon Israel here in Dallas. What are the products you're actually producing? Is it limited to millimeter wave radios, or does it include mid-band or other equipment, MIMO antennas, etc.? It sounds like you just, yeah. So give me the meat. What are y'all making?
Yep. So good question. So our initial products are advanced antenna system radios, so which are starting off with millimeter wave. And so in the millimeter wave radios, they have integrated antennas, right? Because there's so many, so it's like MIMO, but with a lot of antenna elements. So instead of having a separate radio, it's all integrated. And so that's what we're making now. We do have multiple product lines. So there's different frequencies of radios. We also do baseband boards, and but it's predominantly for 5G advanced antenna systems. But because there is a product mix in there, I don't think I talk about it here, but we do have to accommodate. So, you can design a line that perfectly makes one thing, right? And you can optimize that. But if you have to make the second thing, then you have to change that line. And then a third thing and a fourth thing. So we had to accommodate that. And that's why, actually segue into this slide, AMRs are important, right? So if you think about it, you can make an assembly line perfect for, with conveyors and stuff like that for one product. But as you move between stations and do different things, then you have to have that product agility, like I mentioned, is important, right? Mass customization. You need things like autonomous mobile robots, sometimes they're called AGVs, autonomous guided vehicles, to move stuff around, right? So if you didn't have this, you'd either have to have a big conveyor system or people, right, lugging around radios and stuff. But when it's, once a radio's constructed, right, it gets heavy enough that you don't want to have people straining themselves, moving them from station to station. Also, they're expensive and delicate, so you don't want them to be subject to handling or static electricity. So by automating things in a flexible way, AMRs have helped us reduce cost and be efficient. And the reason AMRs are good is, so most factories and warehouses you visit have some form of automated vehicle, right? Usually they go into warehouses and do lift a pallet and move it somewhere. In our case, we do that. Plus we're using them. Oh, sorry, hang on. We're using them in more ways because we're able to deploy a greater amount of sensors and more detailed mapping. And so by applying 5G to our AMRs, we can actually have them navigate through narrower areas amongst people, as well as doing the longer distance runs from material handling, finished goods, and then the work in progress within the manufacturing floor. So that's kind of a difference, is that as you're applying it in more and more use cases where the ability to precisely park in front of a test station and offload the product from a conveyor belt, being able to precisely navigate and find out where you are and see obstacles is important. And so we're able to improve that by having the better connectivity, right? So working with the vendors, we could update maps more frequently, right? So we're not as worried about bandwidth. So no matter where the fleet of AMRs are, they can all be updated with mapping. And also, as you've probably seen on a lot of videos, right? AMRs move kind of slow, right? They're going like at 1 to up to 2 meters per second. And 2 meters per second is considered pretty fast because you have to always be aware of people, right? So as people walk by, or a pallet gets in the way, you need to be able to stop while it's carrying a load. And so the better your sensors are and the farther away you can see, it's like driving, right? If your headlights are bad, you got to drive slow, right? So the more you can see, the farther you can see. Like if you could see through the vehicle in front of you, see around corners, you can imagine that you can go faster while maintaining safety, right? Super important. And so what we're able to do then with 5G is deploy software updates that let us do sensor sharing and frequent map updates. So, kind of going back to that navigation example I gave, where, you've got Garmin and then Waze, and now there's traffic and stuff. So this is like having Waze, right? All the AMRs talk to each other and can say, hey, back there was a pallet on the floor, so drive around it, right? Choose this path. And then they can all be more efficient. So it's all about material movement. So if you had to buy a fleet of X number of AMRs to move, a certain amount of product, now you can have them move more or have fewer AMRs do the same job, right? All while maintaining that safety. So again, really important. And, it's like you're doing something that normally a person would have done, but it's not a good job for a person, right? Because it's just moving stuff.
Hey, Paul, I've got another question for you here.
Sure, yep.
From Atara Sawant, and he says, how is 5G Smart Factory different from Silicon Valley D15 Lab? Which use cases can be solved in 5G Smart Factory that cannot be solved in D15?
Ah, okay, that's a good question. Good awareness of our D15. Yeah, so D15 is a lab that helps incubate, and so they look at, like I talked about proof of concept, right? POCs. So we started off with POCs to say what's possible and how do you get there. Our factory is not about POCs, right? We have to manufacture goods. We have an expectation of a certain amount of product manufactured, a certain quality level, so we can't entertain, hey, let's do this spider that is with a cloud PLC and make it dance. Like we did that at Mobile World Congress and stuff, and that's not what you do in a factory, right? So in the factory, when I talk about this AMR, it is a real commercial AMR, and then we applied a commercial modem to it so that it could communicate better. So instead of Wi-Fi, we reroute the traffic over 5G. So commercial product. And then when we work with the vendor, they're like, oh, hey, we see that the communication, right? So they monitor because they need to make sure their AMRs have, good Wi-Fi, right? So they monitor and they tell you where your Wi-Fi is bad and dropping out or getting interference, and you try to fix that. But once we cut over to 5G, they're like, oh, this signal is way cleaner, has extremely good jitter and latency characteristics. So why don't we do these other things, right? And so it in the factory is not a POC. So how it differs from D15 is we are only taking solutions that are commercially available. So if anyone on this call says, hey, Russ, how do I do exactly what Ericsson did, right? How do I build a comparable factory? They can basically go to all of these vendors and buy the exact same thing. So that's kind of the difference. But it's a good question because that is a distinction, right, between POCs. And, a lot of the literature you're reading is like, well, hey, that sounded really cool. Can I buy a self-driving car and, drive to Austin? And no, you can't, right? we looked at that. We wanted to do something like that, and really, it's a lot of very managed data and very limited scenarios where you can do that. So yeah, this is not a POC. That's a big difference. Okay. So drones for inspection. So, you know, this is a great job. I get to play with drones and get paid for it. But basically, as you know, most factories have warehouses for their inbound goods and outbound finished goods. And we do cycle counting, and then outdoors, you know, we have all these solar panels and everything. So you do have like inspection rounds, outdoor and indoor, where you're looking at things, counting things, and you know, taking record of any damage you see, or you know, all the barcodes that you can read on the products. And sometimes you have needs that are difficult to anticipate. So drones give you that flexibility, right? So normally you could send up a scissor lift to count all the boxes and pallets, or you could go out with someone, you know, doing security rounds and inspecting the solar panels. But with drones, you can use FLIR cameras and things like that. So there's a lot of efficiency gained by using drones. But drones currently require you to have a pilot. And so what we did was we looked at automating that. So building some software in-house, we can actually automate some of the drone operations. So outdoor, you still need a pilot, right? FAA regulations and stuff. But as we automate that, you know, we can apply for FAA waivers. But especially indoor, we can safely navigate in warehouse areas to speed up the cycle counting of pallets of finished goods and inbound. And so what we're able to do then is with the drones, right, connect them up with modems. So, you know, like I said, 5G is really new, right? You can barely get enough variety of smartphones with 5G. So in the space of like modules and embedded devices, right, it's extremely slim picking. So with our current 5G network in the factory, it's called non-standalone. So as you know, in the macro network, you have 4G and 5G. And right now, virtually all of the networks, you connect up and signal through 4G and go to 5G. So in the factory, we have the same scenario where we have 4G and 5G. And so the modems we've deployed in the drones are 4G, right? Because we can't get 5G small enough devices yet. But basically, we do command and control and video streaming through 4G in the drones to enable us to do all of these things. And so it's, again, another efficiency thing where you can deploy technology to reduce the number of people you need to do a certain task, or even if people are needed, they can do it more efficiently. The cool thing about the drones is, you know, we can do them outdoors. So I know you can fly a drone, you know, with your RC control outdoor and go pretty far, but for reliable communications and making sure that you have, you know, full control over everything, we're using 4G, and that gives us confidence that we can go all around the perimeter, look at our docks, look at all the trucks, inspect solar panels, inspect the roof, and everything. And the variety of gear you can put on a drone is pretty impressive, like FLIR cameras for infrared, where it let you detect for heat loss or solar panel damage. So it's a really great technology that gives you that flexibility, right? So I remember after the factory was brought up, before the solar panels were in, you know, we had a pretty big storm in Texas here. And, you know, people had to go in and check everything, right? You know, was everything up? Was there any damage? And so, as you can imagine, if we had the drones operating at that time, we could have had just one person there to be the pilot, but then program a mission, inspect everything, and know exactly, you know, how we were doing in like 15 minutes. So super useful technology for you know, reducing the cost of operations.
Hey, Paul, we got another question?
Yep, sure.
From Solomon, Israel, and he's asking, inside the factory, whose 5G network are you utilizing? Your own or another MNO? Of
course, we chose best in class. No, so it's ours. It's our radios. Actually, the kind of a cool thing is we put up the same radios that we make. So we make these 28 gigahertz millimeter wave radios, and that's actually what we're using in the factory. So hanging up in the foyer is one of the radios that our CEO signed, and so it's kind of a signed radio up there. It was really cool. So yeah, that's what we're doing.
Is it a private network, or are
Yeah,
you?
yeah. So that's a good question. I forgot to elaborate on that. So it's a private network, and so as people probably understand, right? Most of so when you're using your phone and making calls, it's on what we call the macro network, which goes through like AT&T, Verizon, or T-Mobile networks, right? And their radios, and then their network core, and then to the internet. With the private network, we coordinate with an operator, and we use their spectrum and buy the private network from them. And so let's say, you buy it from your favorite operator, they will work with you to figure out what your needs are and scale out how much bandwidth you need and figure out how many radios you need. And in our case, we have the outside covered as well as all of the inside, right? Manufacturing and warehouse with a layer of millimeter wave 5G. And then there's an anchor band for LTE. And in our factory, we also have CBRS, which is so there's an unlicensed and licensed part of CBRS. And what CBRS allows you to do, it's really cool and pretty well unique to North America, is this good amount of spectrum is allocated for unlicensed use. And so you buy a CBRS private network. So we have something called Industry Connect, but there are other competitors out there that are probably pretty good, right? So what you do is you buy this network, and once you deploy it, it will find out. So it can coordinate with what's called the SAS. It's like a spectrum, management entity. So there's different companies that um, perform that SAS function. I think there's like 3 in the US. And so then the SAS says, okay, in your area, these bands are free, and then your CBRS system automatically goes and uses those bands. So let's say you're running a factory with CBRS, and we have a whole bunch of things on that right now. It goes and finds that free spectrum and reserves it for you. So there are many options. Yeah.
I'm sorry, Paul. From the 5G perspective inside the factory, are you guys responsible for the KPIs, right, or is somebody else?
So we're currently managing our own KPIs. So we designed and built the network. We are working with an operator. I don't think I can disclose it yet, just due to NDAs and stuff like that. But we're working with an operator. So as they're launching their private networks products, we're actually using what they're imminently launching and providing feedback. So we're sort of their FOA, first office application customer. So we're the first customer of a product, and we're kind of going through, okay, this documentation wasn't so clear. Well, how about provisioning this? So we're kind of going through all of that with them. So,
Got it.
but as you can imagine, because it's our own products that we sell to them to resell, we're pretty good at operating it. And so we're kind of going through the process, though, to make sure that it's good for future customers. But it is a fully private network. The data stays in the factory. So we have all the radios feed into a core network that's in the factory. And yeah, everything stays inside. So it's an important thing because then you have the full security rate. You know that nothing goes out unless you want it to go out.
Got it. Thank you.
Yeah. All right. So we use augmented reality for a few use cases, so including remote support, work instructions, and expert info. So like I mentioned, right, it's hard to hire people and get them all trained up. And what really exaggerated that problem is COVID, right? So in March, right, we began lockdowns and couldn't travel internationally. And as you can imagine, most of our manufacturing expertise is overseas, right? In Europe and Asia and Brazil, Mexico. So it was really hard to then bring experts in to train people here or fly people from, Texas overseas to get that hands-on training. And so we really had to accelerate our deployment of AR and help enable our people to be trained. I think you've seen in some of our press, we used virtual reality. So like I said, we manufacture 5G radios, right? So it's like most electronics and how they're made. But if, let's say, you're an experienced manufacturing engineer, but you came from automotive or, food processing or something, you have the skills, but you don't know the context that well. So VR allowed them to virtually tour one of our advanced antenna manufacturing lines in Europe. And so they got kind of the feel for, okay, now I know how, as I'm trained, I know the context of what I'm doing and how it all fits in. And then as I'm learning new things with new machines, like, not that many manufacturing jobs require you to stare at a spectrum analyzer and look at the output and make a decision, right? So if you're faced with that and you don't have someone experienced beside you, you basically phone a friend, right? So what we do is we put on like Microsoft HoloLens, or because we have the 5G in the factory, we have software from Microsoft to do AR for remote support, and you can basically show what you're seeing and say, hey, look, this looks unusual. It doesn't match the documentation. Can you help me? So you call an expert. They see what you're seeing. So it's not just a video call, though. They can then mark up on their screen to guide you, right? Well, you have to twist this knob, you have to look for this kind of output. And it really helps speed up that communication, which can be difficult. And that's why typically, right, we fly people around to do that hands-on training. With COVID, we couldn't, and so it really showed us the value of being able to do this. The other thing we did to speed up some of the training, especially for complicated steps, right? Like everyone can put a board on and screw it down, but if you're routing cables or placing gaskets or doing things with, fiber optics, some of the work instructions are hard to describe in text, step by step. So by having AR, you can actually illustrate it with like 3D CAD drawings that you can kind of see through things and understand, okay, how that works. And so we're able to do that. The challenge with work instructions is you have to create content. So we really picked on the most difficult tasks and created content for that. And expert info is where, imagine how when you're driving, right? If you had a heads-up display, you can see your speed, you can see oil temperature. So having information live, that helps you be more effective, right? So if you're troubleshooting something or just looking up documentation, having that at your fingertips, right, while your hands free and doing your job, you're tweaking something, you can see the torque readings, kind of like a heads-up display, through your HoloLens. So these things help improve efficiency. Now, these things aren't, aside from like the remote support thing on a smartphone, they're on HoloLens, so they're not using 5G, right? So we do find sometimes in areas of the factory, the Wi-Fi isn't as awesome, and so we have to kind of keep tweaking that. But they are, very effective in helping people speed up and have more confidence with less training to do their job. So it improves our productivity. And then, so digital twin. So like I said, when you talk about Industry 4.0, right, everything's about data. You just collect all the data. But then you're like, well, okay, what do I do with it, right? So I have tons of data, but I can't like make sense of it. And so what the digital twin does, it helps you represent everything in real time and says, okay, so let's say I have a surface mount assembly line, right? And so normally it's like, when you're driving your car, do you have a check engine light or not? But you don't really know what's going on. And can you do better, right? Can you operate faster, have more throughput of components? And so a digital twin lets you kind of look under the hood and see how everything is done. So instead of just a cycle time for a machine, you can look at the components of cycle time and see if I can actually do better, right? And so digital twin lets you take the data that you have, organize it, and model the interactions so that you understand how everything kind of fits together and how things affect each other. And so remember I said in the beginning, be careful when you use terms like digital twin. It means a lot of different things to different people. And so one thing, we have many digital twins, in fact. So we have a digital twin where when we construct the factory, right, you can't just, it's like when you're buying furniture for a new house or something. right? You have a piece of paper and you're like, okay, I'll put this machine here. And well, you know, you can't, or I guess you can, but you can put it in AutoCAD or something. But we actually create a digital twin to make sure all the robotics have room to move, that the AMRs can shuttle between test stations and go between workstations and grab product and deliver product, right, from warehouse and stuff. So we actually have a digital twin. But when you design something from scratch, and that twin is really a CAD representation, it's a simulation. And so, you know, internally we had some confusion around, well, we have a digital twin already, right? Why is the factory, you know, looking for another digital twin? And the key is that once you've built this thing, right, the simulation shows what you should be able to do, right? The digital twin we were looking for is to say, well, what is it actually doing? How do we know we're operating as well as we can, and what happens if we're asked to do more, right? So where is the next bottleneck? What should I do? And when we have a new product, right, how does that affect my current productivity? Do I need to buy more AMRs? You know, so that kind of thing. So digital twin, basically what it's helping you do is take advantage of all your data to give you operational efficiency. And so this is a big deal. It's the all-encompassing thing, right? A lot of the smaller solutions are, you know, we have a great SMA line, great final assembly steps, and everything's robotized. But when they all fit together and the manufacturing execution system tells everything what to do, where are the real bottlenecks, right? And the digital twin helps you figure that out. So similarly, so digital twin talks about the whole production, the machinery and everything. Digital thread is about the stuff you're making. So as we make radios, right, we have board serial numbers. We test boards incrementally, and boards pass through different machines to get components placed. And they go through different steps and inspections. And because it's radio products, we test the radio frequency performance as well. And so everything is stored. So we've got tons of data. And like I said about digital twin, right, you're modeling the interaction between machines to understand patterns. Digital thread models everything about the product, right? It's object oriented. And so you take everything about the product, including through its life cycle. So once it's deployed, as it's operating, is it maintaining temperature well, right? Does it have the right RF performance? You know, so if you have an issue, you can quickly find out, is there a pattern, right? So what you're looking for is, you know, let's say you have an overheating issue or something. You can then say, okay, the units returned, what was common about them that's different from the ones that weren't returned, right? So digital thread lets you do that evaluation. So it's less about the production and about the product, but it's similar, right? It's using the data, helping you model it, creating that structure. And this is where you can apply machine learning and AI to speed that up, right? It's hard for people to look at everything and say, oh, wow, every time we manufactured a radio when it was like, you know, hailing outside, we had a quality problem. Well, that's really hard insight to get because there's so many data and you don't expect that to be a factor. And if it was, you know, that's where AI and ML kind of apply its magic, right? And so that's where we're headed. Now, digital thread isn't something that you can really buy. Our finding is that, you know, we actually had to write that kind of stuff in-house. And so that's where, you know, data scientists really come in, and having a bunch of broad expertise to be able to do that. So, but super valuable, I think, in every industry, it can be useful. Right, so some takeaways. I think I'm good on time. So if you're sleeping through the rest of it, here, you know, you can wake up and take a screenshot. But to summarize, it's all about the data. Everything I talked about in terms of the process and stuff like that, you know, in creating agile teams is really bringing different tool sets to bear, right? So I've got a whole bunch of data. I've got these problems to solve. How do I do it, right? So 5G is one part of the answer. AI, ML, video, augmented reality, cloud compute. So we do use cloud compute. We use mobile edge compute, right? That's what MEC stands for. So all of these are basically tools, right? Where do you store the data? Where do you process it? And if you can think of like, why is there so much hype around 5G? is because it came in at the right time to say, we've got really great advances in AI and machine learning in the past, say, 3 to 4 years, right? It kind of came in big. Video is cheap, augmented reality is getting better, cloud compute is big, right? Amazon, Azure, Google, and mobile edge compute where your servers are able to, containerize and you get more solutions to process stuff at the edge. And 5G then lets you get data to the edge and back, right, in an agile way. So you're not waiting to cable something up. If I want to put a 4K camera to monitor something to do inspection, I can do that without a lot of planning ahead, right? I don't have to wait and get an electrician and cable up an Ethernet to that spot and go, oh, that wasn't the right spot, and then do it again, right? So that's kind of where 5G comes in. It gives you that agility to just change everything up, right? So, re-summarizing, think about the business outcome though. Just because drones are cool and it's fun to fly, you really do have to seriously think about, well, can I do this without drones? Like, so there's some places where like you can have a fixed camera, right? So if I could put a fixed camera that could inspect my solar panels, I would do that. Why would I fly a drone? The thing is with the solar panels where they are, that's really hard to do, and you'd have to get permits and build, trench a whole bunch of stuff to get this. So that's why you look at the business outcome and say, what's the best answer, right? Don't have an answer looking for a problem. And then the agile teams from diverse backgrounds was super important. We got to do this. I don't know if it's unique to Ericsson, but having the diversity of backgrounds means you have more tools at your disposal. There might be an AI expert. I know 5G, and we can, come up with the solutions really quickly and be very creative. And because I know we had to pivot a lot in terms of our ambitions, do an MVP, right? So minimum viable product or project or whatever you want to say. Have something quick to give you feedback and confidence you're on the right path. Maybe chose the right vendor, chose the right technology, and then adjust as necessary. So that's it.
Hey, Paul, I think you just answered another question here. Let me just make sure. Solomon asks, are there new management tools that you're creating based on your experience running the network for your own factory? Sounds like that would be a yes, I guess, huh?
Management tools, yeah. So we have like, in the factory, you want to have a dashboard and situational awareness. And so we've created a lot of screens to tell us, how are we doing? What's the utilization rate of different things? Are we using everything properly? And so there are management dashboards, and then the digital twin lets us figure out, well, where are there optimizations to be had? So we have, many layers of management control.
Got it, thanks. Paul, one more question. And this is from Raj D. And he says, how will academia and startups participate and engage in the 5G Smart Factory, POC? What will the business model be and IP protections?
Yeah, so the factory itself won't entertain POCs, like proof of concepts, right? So we wanted to get away from that whole POC idea and, duct taping stuff together and saying, hey, look, it's 5G, right? Where academia and others come in and startups. So we work, and that's going back to D15. So what they do is they actually engage actively with partners and try to support that. So there are labs in Santa Clara. We have labs in Germany with Aachen, Sweden, of course, and even in Plano, and a lot of our customers too, right? AT&T, T-Mobile, Verizon. They also have many things that we support that are POCs, and they help people bring stuff to market. So that's, you can reach out to me if you have a question on specifically how you engage. But I know we've done like robotics and mapping and mixed reality. And in Canada, there's a program called Encore, ENCQOR, that is similar to what we do in Silicon Valley, where the Canadian government is also in on this, trying to stimulate startups and using 5G and technologies to, improve the tech ecosystem there. So I think just reach out to us, and we have many different mechanisms. The factory is really not that playground. We are looking at that specifically to help better enable industrial startups and solutions to come. So as you can imagine, our AMR vendor have has an advantage working with us because they're like, hey, we like the idea of 5G, but we don't have modems, we don't have the antenna skills, and we're like, oh, I can help you with that, right? So definitely we can facilitate, and yeah, good question. So if you're interested, that Simone Gertz YouTube thing, she's super funny. She creates robots that are really goofy on purpose. But it just kind of shows you some of the frustration you might get into if you're trying to apply something that isn't ready for prime time. Yeah, pivot, MVP, pivot.
Is this your last slide, Paul?
Yep, it is. That's my ending. Yep.
Great. So everybody, what we'll do now is we'll conclude the presentation part of the program now, and we'll just kind of open it up for 30 minutes or for however long you guys have some questions. And this way, what we'll do is if you can raise your electronic hand and just unmute yourself, I'll call on you just so everybody's not walking all over each other. And then unmute yourself and ask your question or make your comment. And we'll just go here for 30 minutes or as long as you have questions or comments. So we'll start that now.
I see a question on chat, my contact info. I guess I can throw up that slide again with my LinkedIn, but basically it's, you can find me on LinkedIn, Paul, TSE, and we can connect.
Okay, I'm scrolling. I don't see any hands raised.
Thanks for the encouraging feedback. Appreciate that.
Questions, anyone? Comments, anyone? Hey, Paul, I've got one. So is this the first of many 5G factories, right? Are you outfitting Yavle and some other areas of the country to do the same thing, to support their market areas?
Yeah, so there are other factories actually globally too. There seems to be sort of this race to be first. So I think we're the first in North America with a full 5G network. But like I said, we support our customers. So you'll see that most of the major operators have their own labs and stuff. I'd say we're probably the first using it in full production. So not a POC, right? So it's not just slapping, a 5G modem to an AGV and just replacing Wi-Fi. Like we're integrating it and using it. So I'd say we're the first trying to do it at scale, right? And what we're trying to do is share the lessons like through Tech Titans and other forums to say, well, here's what you can get now. Here's what's kind of in play. Yeah, so yeah, I'd say we're the first, but not the only, hopefully. Great.
Right. Anyone?
Yeah, having trouble with the electronic hand raiser.
Solomon, go ahead.
Yeah, Solomon.
Sure, since I've been monopolizing most of the questions here. Paul, first off, fabulous job. So, and great to see what you're doing. Just a variation really on that last question around this race around using it. I was just curious, what other factory, are you aware of other factories or use cases where people have used 5G as part of, automating and increasing the flexibility of factories that are worth looking at? Did you use, what were your study points? It all really done, from the ground, from a zero base? Was there anybody else that you collaborated with or learned from?
Yeah, so I guess, we have the advantage of, because we're one of the earliest 5G vendors, and we then support our operators to do their POCs, and we've been at Mobile World Congress, we do Hanover Mess. So we have this great vantage point of seeing all the cool ideas and what's ready and what's cool but not quite ready. And so I think we benefited a lot from that. Especially in terms of getting ideas for So it's not always like, what can I buy today, right? It's more like, if I buy something today, will I see a path to it getting better tomorrow, right? And so that's why we're excited about using, like, for example, video as a sensor. You can do optical inspection of stuff, but if you're stuck with what the manufacturer gave you and you got to keep that machine for 10 or 15 years, it's not going to be state of the art in 10 or 15 years, right? And so the cool thing about being able to, compute on the edge and having something like 5G is we can apply our own sensors and keep upgrading them. We can have better trained AI models to inspect for defects, for example, and keep training it and getting it better and better, and not have to worry about software downloads and blah, blah, blah. So we see all of that and get some of the best ideas. And that's why we want to share back, right? It's like, well, here's what we've learned. Here's what we think you can do. And here's what's ready, So it's been great. And hopefully we keep that ecosystem going. Like, so like, we don't want to be selfish and say, oh, we're going to have the best factory and la, 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 because there's an ecosystem thing, right? It's better for us to have success nearby because critical mass helps everyone, right? So, yeah, so we're benefiting and hopefully feeding that back.
Thank you.
Looks like I'm not seeing any electronic hands, so just please feel free and jump in if you have a question or a comment.
I know I've been asked before about like COVID and how that affected us. Like I said, we have had to accelerate things, and we have applied a lot of controls. So we, temperature check. Some of the things are voluntary, but we also have we use cameras to check for compliance. So originally it was around PPE, right? So if you're going into construction area, we can put up a temporary 4G camera and see that you're wearing, your hard hat and goggles and stuff. So PPE helps to ensure compliance, because sometimes you forget, right? You're walking around the factory. But then when COVID hit, we could quickly adapt. And again, because it's cloud processing, we could add a mask compliance thing. So we can now check if someone's wearing a mask and, just remind them, hey, dude, you got to wear a mask, right? And so I think that's kind of an example of how things like 5G, right, gives you that agility to deploy solutions like that rapidly, and cloud compute and AI ML. Like, if you didn't have that, imagine how hard it would be, right? You'd have to station a security person there. And so we really felt that gave us agility. So it's not just about, can I manufacture more widgets more quickly and cheaply, right? It's, can I maintain safety of my staff and take care of everything, even in these challenges. So that was really cool. I thought we did well there.
Okay, I won't be shy, and I'll take advantage of you being here
No,
again.
sure. Like
You said a couple of times that you pivoted, and you use the minimum viable product or project concept. Is there something? What surprised you? What did you try to do that you thought was going to be a layup shot that turned around as, wow, that was actually not turning out the way you thought, and so you figured out and you moved on to something else? But I'm just curious from a learning standpoint, if there's some examples that you can share.
Yep. So one thing I was really excited to try to do, and David Hart, who leads the Industry 4.0 thing for the factory, say, hey, Paul, go check out self-driving vehicles. And, I like cars, and I'm like, dude, I'm on it. And, in 2018, right, you read all the literature and about Tesla and a whole bunch of companies, and we're suing each other and saying, we're imminently going to have self-driving cars. You don't have to get a driver's. So my daughter, I was like, oh, don't even get your driver's license, right? Just you're going to have a self-driving car in 2020, right? Even Ford, everyone was saying this. So I thought, okay, slam dunk. We're going to have a self-driving vehicle, ship finished goods from the factory to our warehouses. I'm like, that's great. So we shopped around, and guess what? You can't buy that. So, well, I mean, you can buy that, but it's super, super micro-engineered, right? They have to do LiDAR maps of every intersection and every place, and so it's not really practical. So we pivoted from that, to looking at like drones to help solve some of that problem, right, with shipping efficiency. But yeah, that was something where you can't get too in love with an idea that's maybe too far out there, right? There are other things around, like even our compute strategy and how we organize data. So construction of like a data lake and organizing data. It sounds trivial, like you just save it to Google Drive, right? But it's not, like, because to make sense of it, you have to have it right, the correct timestamps. Every vendor has a different way of representing their data. Is it imperial or metric? There's all sorts of crazy stuff that you have to take care of. So we did have to really micro pivots, right? Small pivots there in terms of our ambitions for protocols to use, right? OPC UA, oh wow, that sounds like the right thing, but guess what? No one supports it. So you have to then create translators and work around it. But those are smaller pivots, like, it was still the right thing to do. We just had to get different software built to handle it.
Hey, Paul, I've got one.
Yep.
Looks like Dennis wants to know, do you have a reference price for deploying a private 5G network for 10,000 or 100,000 square foot? Is there something like like in the old DAS business, right? You have like a price per square foot, right? For a DAS. Is there something similar to a 5G network that you've computed?
No.
Okay.
Sorry. So I don't, because so I work with operators to figure out how to use technology. I guess someone else writes the checks, so I have the luxury of just spending money. So I'm gonna say I don't know. Great question, though. I'm glad I don't have to know. No.
All right.
Sorry.
That's all right. All right. If there's last opportunity for a question. Okay. Hey, Paul, I think we're done. So.
Yep, super. Well,
All
definitely reach out on LinkedIn. If there's something you want to ask in private. Like I said, we really want to share and help people, go through similar journeys, right? So.
Sure. Well, let me close this out. Paul, thank you very much. Really appreciate you coming out here and presenting today, spending the time with us. I think a lot of folks know we've been trying to do this for a long time. We actually had an in-person program at the factory, right? We were trying to get this in March 27th, I think. So
yeah, and then something happened, and
that's right. So thanks so much for the last 6 months or so to help us get this virtually scheduled. And maybe in the springtime we can do something bigger and grander, at the factory, right?
Yeah, cool.
And everybody else, thank you for joining. I hope everybody picked up a nugget or two on industrial automation, smart factory, industry 4.0. And we'll see you again in 2021, maybe at one of our next events. Thank you all very much. Have a great Thanksgiving.
Okay. Thank you. Yep. Take care.
Bye-bye.